A good day to everyone. This is Traffic Impact Assessment for Sustainable Urban Engineering as presented by Kim Nale, Nale Travilla, and Anton Villanueva. Transportation is a vital part of economic growth. The movement of people, goods, and services provides major economic opportunities for the community, encouraging development. Traffic impact assessment is an important tool for assessing the possible impacts of traffic generated by a proposed development to the surrounding transportation system. It helps the developers and urban planners in forecasting the future conditions of the network, allowing further specifications or alterations in its design process that improves or accounts for the existing and potential traffic conditions. Moreover, with identified traffic conditions, land use optimization and road network design will be easier to facilitate due to the collected traffic data and projections. To preface, these are the common terms that we will encounter throughout this presentation. Travel demand is the quantity and type of travel people would choose under specific conditions. For example, for short distances, people tend to walk, or for long distances, people tend to travel by car. Origin destination is a movement of people or trips between 2 points from an origin to a destination. Traffic volume is the number of vehicles per unit of time. This represents how crowded a road link is. LOS, or level of service, is the quality of road network service. To put it simply, it describes how fluid a road network is. A road junction is a location in a road network where traffic can change directions and routes. Urbanization is a major force that catalyzes growth and development. Cities are centers of economic activity, thus naturally, it encourages population movement. However, without careful planning and management, it gives rise to detrimental issues and consequences. Traffic congestion stems from extensive development of certain areas without regard to equivalent transportation infrastructure like roads, parking, and etc. These significant developments that are usually commercial or industrial in nature, are attracting huge volume, motor, and pedestrian traffic. With the increase of the population comes the challenge of accommodation. Appropriate facilities should be available. However, if not monitored, it encourages the formation of slums, which are areas with poor living conditions. The increase in demand calls for an equivalent increase in supply. Thus, more energy, food, and water is produced or imported and consumed by a highly urbanized city. There are more cars, industries, and people contributing to the pollution of the environment and emission of greenhouse gases, which contribute greatly to the global climate problem. Thus, with sustainable and optimized land use and transportation planning, these disruptive circumstances can be alleviated and improved. Traffic Impact Assessment, or TIA, is a useful planning tool that is commonly utilized by local governments, especially for traffic management and planning, for projects regarding their respective transportation systems and road networks. Traffic Impact Assessment is performed in locations where potential development projects are performed in close proximity or adjacent to major road networks. Traffic impact assessment is also most commonly performed when the road networks adjacent to the said development projects are crucial enough that potential problems that can be caused when the development is pushed through, such as unforeseen congestion and/or safety issues of the latter road networks, lead to massive impediments to the said road networks. Traffic impact assessments are a requirement to development projects since changes in traffic determine if the development project necessitates changes in the public transportation system. Traffic impact assessment studies are performed in the latter areas in order to obtain the following transportation variables and data: traffic volume and road capacity, parking supply and demand, road capacity and LOS, and probability of accidents and safety issues to occur. Traffic impact assessment studies are performed by traffic consultants and consists of 5 major stages. First, determining the scope of work. Second, the collection of traffic data. Third, the actual traffic impact assessment. Fourth, visualization of impacts of development and remedial measures to mitigate said impact. And lastly, the creation and submission of the TIA report. In determining the scope of work, the traffic consultants determine the study area in which the traffic impact assessment study is to be performed and the specific locations within the study area where primary data will be collected from. Next, primary and secondary traffic data is collected by the traffic consultants and engineers. Primary traffic data consists of data obtained firsthand by the traffic consultants, traffic planners, and engineers. These sets of data are commonly obtained by traffic surveys performed on-site or via technology that allows automated data collection, such as AI-based video analytical data collection, technical traffic sensors, and etc. Secondary traffic data is obtained from existing road traffic volume data obtained from the government, the local authorities, and/or past traffic analysis studies. After the collection of data, proper traffic impact assessment is performed wherein using the data obtained from both primary and secondary data collection, the possible impacts of the development project are forecasted and analyzed. To specify, the traffic consultants and engineers performing the assessment focus on the analysis of existing traffic conditions, forecasting any possible growth in traffic caused by the development, changes to trip generation and distribution, identification of issues and problems that the development would pose to the roads and junctions adjacent to it, and the proposal of traffic and safety risk mitigation measures that can diminish the above impacts caused by the development. After the impacts, issues, problems, and mitigation measures have been made, the traffic consultants and engineers will then visualize or model the said impacts and the effects of their proposed mitigation measures using traffic simulation software to formulate a clear assessment before sending the results of their traffic impact assessment study to the needed authorities. To show the relationship between traffic impact assessment and sustainability, we will present two case studies, one in Asia and one in Europe. The study in Asia compared two developments in Metro Manila with their compliance with TIA for the sustainability of traffic management. The first development is Sky City. This project was envisioned to be the tallest building in the Philippines. Unfortunately, the developers failed to provide any effort to address its potential traffic impacts. As a result of their failure to conduct traffic impact assessment and their blatant disregard for the stakeholders' concerns, the EIARC rejected its application. On the other hand is the 670 Heights development, a 40-story mixed-use building representing the ideal situation. The developer had complied with the EIARC recommendations and recognized the importance of traffic impact assessment. These assessments include the level of service case scenarios from 2004, 2009, and 2020. The developer was granted an ECC and the project was scheduled for completion in 2006. From this comparison, Regidor developed three components that advocate traffic impact assessment for sustainable traffic management in Metro Manila. The first focuses on developing management plans, forecasting traffic congestion, and developing solutions to perceived problems. The second highlights the importance of government involvement in requiring traffic impact assessment. And the third emphasizes that the reliability and completeness of traffic impact assessment are essential for it to be functional. The next case study is about the impact assessment of sustainable mobility in Europe's 6 touristic cities. The European Commission funded an initiative to implement solutions in these cities. Amongst the study's priorities is to apply a consistent and efficient methodological framework to assess the impacts of the designed mobility measures. In this case, the traffic impact assessment comes into use in achieving sustainable urban development of these 6 cities. They are able to provide 11 mobility measures in the city of Rethymno, which are summarized in the slide. As shown, all of the 11 measures can be categorized according to environmental, social, and economic aspects. The environmental aspect includes 1. The active, healthy, and inclusive mobility for all by promoting a car-free lifestyle. 2. Introducing electric vehicles for public transport. And 3. Introducing solar-powered EVs charging points. All of these aim to maintain a viable natural environment. The social aspect includes 1. Behavioral change of citizens towards sharing mobility modes. 2. Addressing the traffic congestion surrounding schools. 3. Upgrading public transport services with rescheduled plans and operations. And 4. Combining the needs of tourists and residents. All of these aim to nurture the community. The economic aspect includes 1. Involving smart systems for urban planners, operators, and users. 2. Optimizing freight distribution to decrease traffic congestion. 3. New products and services combining tourism and mobility. And 4. Setting up a business model to operate biodiesel chains locally. All of these are done to suffice the economy. The presented case studies have proven that communities need traffic impact assessment as an essential guide in sustainable planning, development, and forecasting of impacts. For a transport system to be sustainable, it must fulfill its 3 pillars such as environmental, social, and economical, which was highlighted in Case 2. Case 1, on the other hand, has emphasized the importance of traffic impact assessment in policies. Developers must not neglect or take these assessments for granted, especially when they are situated in traffic areas. The government and development agencies must also take an active role in promoting traffic impact assessment. Traffic impact assessments have been proven to consider the systematic impacts of projects, which make them a great tool for sustainability. Thus, traffic impact assessment paves the way for communities to present solutions in the realm of transportation and sustainable development as a whole. That is all for our presentation for today. We hope that you learned something about traffic impact assessment and its role in sustainable development in engineering. These are our references.